I actually struggled on this one because I didn't draw the picture for this experiment or this problem correctly. So maybe you'll do a better job than I did as you read this question. But you've got the slide that goes like this, and then there's a gap here, and then there's the water. And the question is how far, we'll call this x, we'll call this x1 and this x2. What is this gap? Do they fall? Because what do we know? We know that the person has some potential energy up here, mgh, okay? And at this point, they have kinetic energy, all of this potential energy, all of this potential energy, and this height was given. This is 3.1 meters, and this height is the 1.5 meters. So it's actually a total of 4.6 meters in falling. And of course, then what you want to do is I need to find out what the speed of this cat is, right? His horizontal speed. What is this v? And of course, you can say mgh equals 1/2 mv squared, where this h is 3.1, and you're solving for v. The m's, as you can see, will cancel off. And once you know this v, this is the v1. Now we're in a, what we call more of a kinematics question. Okay, this is a v, not, in fact, I should call it v1. I'm going to call it vx. It's moving only in the x direction. Got it? So once you have found this v, you then have to use kinematics equations. So if you recall, an object falling in the y direction, this is the y direction, this is the x direction, is I can say y2 equals y1 plus v1 yt plus 1/2 at squared. Y2, we're going to say y2 is this 0 mark, equals 1.5 plus, in the y direction, it's not moving. Do not put your vx that you calculate, you'll need this later. This is the vy, so this is 0t, so that just crosses off, plus 1/2, and on the earth, negative 9.8 t squared. You need to find t, so find t. You're going to get some number t, then you're going to use the other kinematics equations, x2 equals x1. Now we're at the x, right, plus v xt plus 1/2 at squared. You're trying to solve for x2. x1 is 0. v1x is this number right here that you calculated. Boom, that's what you need that for, times the time. And it's not accelerating. Remember, in the x direction, this is not accelerating. That's 0, so that's a 0. So it's just going to be just your velocity, boom, times your time, boom. And that's how far x2 is. And the question asked, does the mass matter? The answer is no, because as we saw here,